Hi everybody, welcome back once again to this channel. Thank you very much for joining us once again, and we are still continuing revising your trial exam paper, and this is a question from the Northwest Province. It was question 5 under function, and we're just going to explore it. Quite very interesting question, really. A lot of people have been asking to say, can you please do this question, and we're just going to explore it and see how it goes. All right. Guys, if you're new to the channel, please make sure that you have subscribed. Just turn on that notification bell so that you can be notified every time when we upload a new session. And again, guys, you can join our membership. There's some interesting sessions that will be released. I think some of them have been released already for our members. So make sure you have joined our membership. It's just from a minimum of R9.99. All right, without wasting any time, let's get into it. Okay, question 5. So we are given quite a number of graphs. We have the graph of G, there is it, f of x, there is it. They are sketched below. We are given the line h of x, which is x minus 1, is the axis of symmetry of G. Point A is the x-intercept of G. We can see there that A is on the x-axis, so it's the point of intersection of what? Of the graph of G, right? As well as it's also the x-intercept of the graph of H there, if you check. So A and B are the point of intersection of G and H. So you can see that the point of intersection there of the graph of G and H, and the axis of symmetry of F intercept the x-axis at A, right? And we are also given C as the turning point. Everything is represented here. D is the point on F. D, a point on F, is actually the point of intersection of the asymptote of the graph of G, right? So they are telling you that this hyperbola here, you have another point of intersection of its asymptote, right? And that is point D. So 5.1, they want us to determine the coordinate of A. So if you check A is a point that is found on two graphs, the graph of G and the graph of H, and it's also the x-intercept of both of those graphs, right? So we can just go and check which equation are we given. We have h of x there, which is x minus 1. So to find A, I know that A is the x-intercept also of H, right? It's cutting the x-axis on the graph of H. So I can just get the x-intercept of H of x by letting y to be equals to 0, right? So basically 5.1, I'm just gonna let y to be equals to 0, that is h of x to be 0, and so for x, right? So x will be 1, and you can see point A will just be 1 and 0 there. Okay, for 5.2 now, it says show that the coordinate of D is given by -2 and -3, right? If you check coordinate D is there, right? We are told that D, it's basically at the is the point of intersection of the axis of symmetry of the graph of G, right? So it's somewhere there, and you can see that if this D is the point of intersection of that axis of symmetry, then it's also the point of is the midpoint of AB, right? AB, if you check AB there, so there's equal distance from D to A and equal distance from D to B, right? So D is also the midpoint, at the midpoint of AB. So we can use that idea to solve for the coordinate of D to show that indeed it will be equals to -2 and 3. So we are saying x at D is the same as x at A plus x at B divided by 2, because it's at the midpoint, right? So you just say x at A, it's 1, plus x at B, it's -5 divided by 2. This will be 1 minus 5 over 2, which is -4 over 2, which is -2. Okay, then y at D, basically the same. It's at the midpoint of AB, so it's y at A plus y at B divided by 2. So y at A is 0, y at B it's -6 divided by 2. This is -6 over 2, which is what? Which is minus 3, right? So you can see clearly that D is the point minus 2 and minus 3, and we have shown, right? Let's quickly go to 5.3 now. So 5.3, they said determine the equation of G, right? So G is the what? The hyperbolic function. So to determine that equation, obviously you must know the asymptotes, right? Because R and T are the asymptote. The other one is the vertical asymptote. The other one is the horizontal asymptote, right? So to get that equation, we are given g of x equals to a over x plus r plus t, right? So you must know what is r, what is t. Those you find on the axis of symmetry, and we are told here that D was actually at the point of intersection with the axis of symmetry. Therefore, we can deduce that the x there of that line, it's minus 2, its y, it's what? It's minus 3, right? So we can just come and substitute g of x is equals to a over, so for the vertical one, it's r, right? But when you substitute there, because x is minus 2, when you substitute, remember to change the sign, because at the end when we say x plus 2 equals to 0, x equals to minus 2, we must still get that minus 2, right? So just be careful with that. When we substitute the one for x, we change the sign, but the one for y, we keep the sign. So y equals to minus 3 will be our t, so t is equals to minus 3 there. So we are left to solve for a, right? So to solve for a, obviously you just get any point on the graph, right? On your graph of G. So we have a point A there, which is 1 and 0. So I'm just going to substitute point A, which is 1 and 0. This is x, this is y, and solve for A, right? So where there is y, we're just going to put 0. Where there is x, we're going to put what? We're going to put 1. So it's 1 plus 2 minus 3. 3 will go that side, and a over 3, then a will be equals to 9, right? Then finally our equation g of x is 9 over x plus 2 minus 3. That is the equation of g of x, right? Okay, 5.4 now. 5.4, it says show that the equation of f is f of x is equals to x squared minus 2x minus 11, right? But you realize that what you are given there, it's given in terms of the turning point, right? So you can see that the turning point of f is c, and obviously those are symmetrical like that. So x at c is the same as, x at a is the same as x at c. So that is 1, right? But we don't know y or q, right? We don't know it. So we're just going to go to this equation. We substitute. Remember also for the x, that's where you change the sign, right? When you're substituting in the turning point there. So instead of putting it as plus 1, you put it as what? Minus 1 squared. Because at the end, when we equate this to 0, we want this to still give us that 1, right? So just be careful there. Plus q, we don't know q, right? So we can just go on the graph and substitute any point that is on the graph of f. So I can see D, it's also on the graph of f. So I'm just going to substitute point D, which is minus 2 and minus 3. This is x, this is y, and so for q, right? So where there is y, I substitute minus 3. Where there is x, we put minus 2 squared plus q. When we simplify this, minus 3 is going to be equals to minus 1 minus 2. Minus 2 minus 1 is minus 3. Squared will be 9 plus q. Then when we solve for q, it will be minus 3 minus 9, which is what? Negative 12. All right. So after getting negative 12, we can just come back and put our negative 12 there and actually expand this equation so that we show that it's indeed x squared minus 2x minus 11. So when you expand this equation, it's going to be x squared minus 2x plus 1 minus 12, right? So when you simplify, you add like terms, you'll get x squared minus 2x. 1 minus 12, it's minus 11. Then you have actually shown that indeed the equation of f is that, right? Let's quickly go to 5.5 now. Okay, 5.5 now. Determine the x-intercept of f, right? So this is 5.5. So we have f of x equals to x squared minus 2x minus 11. X-intercept, let y be 0. So I have x squared minus 2x minus 11 being equated to 0. You can just simply use your quadratic formula, minus b plus or minus root of b squared minus 4ac over 2a. Then our a is 1, b is minus 2, c is negative 11. Then you just substitute there. So it's going to be minus into minus 2 plus or minus root of minus 2 squared minus 4. Our a is 1, our c is minus 11 divided by 2 into a, which is 1, right? So when you solve for x it's gonna be let me see, 4,46, or another x is gonna be negative 2,46. all right, so those are our x-intercept. Let's quickly go to 5.6 now. So 5.6, it says, for which values of x will f prime of x times f of x be less than 0, right? So basically with this question, it's just for 2 marks, guys, and you'll find people going and derivate and coming and substitute to solve it algebraically. You don't have to do that because it's just for 2 marks. You just need to observe, right? But to guide your observation, for these 2 graphs, when you multiply to be less than 0, the other one is the derivative, is the gradient, right? So it's when the other one is negative and the other one is what? Is positive. So that when you say negative times positive, it gives you a negative, right? And we know that all negatives will always be less than what? 0. Or when the first one is positive and the second one is what? Is negative. Okay, so that's the idea really. So for the gradient, you don't have to even find the gradient, to derivate, you understand. So you can just basically represent where is the gradient negative and positive by just looking at your graph, right? So looking at the graph of f here, how do I highlight where my f prime of x is negative? It's where the graph is decreasing. So your f prime of x will be negative. Okay, so as we are going down, this part is negative. So my f prime of x is becoming negative up until we reach the turning point. Then when we go up here like this, from this point going up, your f prime of x, or the first derivative, will be positive. That is, it will be increasing, right? So I can just represent that using positive. Okay, so now you know where your f prime of x is negative and positive. Then you can just go and check where the first thing we are checking is where the other one is negative and the other one is positive, f prime of x and f of x, right? So that we just check that interval there. So where f prime of x is negative, we can see it's from this turning point here where x is equals to 1, right? Up until going that side, okay, where x is less than 1, going that side, it's negative. But at the same time, we have to check where the graph of f is actually positive, right? As much as the other one is negative, where the original graph now, f of x, is positive, that is when it's above 0, above the x-axis. So you can see that the graph of f, it's above the x-axis at that point there, right? Hence the previous question say find those x-intercept, and that point there, it's negative 2, maybe let me write in red, minus 2 comma what? Minus 2,46, right? Because this side will be 4,46, the positive side. So from minus 2,46, the graph of f, it's above 0, right? The black one, this black one, it's positive, right? It's positive, it's above 0, right? But the derivative, its derivative, it's what? Is negative. I've represented the derivative using green there. Can you see? So that's the point where the other one is negative, the other one is positive. It's when actually x is less than what? Minus 2,46, because it's from that point going that side, going to the left, where you find the other one is negative, and the graph is actually above 0 there. That is, it's positive, right, when x is less than minus 2,46. Or we go and check again where the first derivative is positive and the actual graph is negative, that is, it's below the x-axis, right? Where the first derivative is positive, I've highlighted in green, that is where the graph is increasing. So that's from 1 going towards positive infinity, right? But then we have to check where the graph is below 0, right? So you can see the graph, maybe let me use a highlighter here. The graph is below 0 here, right? It's below 0, it's below 0 there. You understand? The graph is below 0 there. That portion in yellow, that's when your graph of f is negative, it's below 0. But we have to check where the graph, the first derivative is positive. I highlighted it in green. So it's between 1 and 4,46, where the graph is actually negative, but its derivative is positive. Can you see in green there? So it's between those two intervals. We can just write that it's actually when x is less than 4,46 but greater than 1. That is, we are finding that the graph is under 0, it's negative, but its derivative, it's actually positive because the graph is increasing there. Okay, I hope you understand that. So that will be your answers for 5.6. Okay, let's quickly go to 5.7. Quite very interesting. 5.7, very interesting. They are saying calculate the maximum value of f, second derivative of f of x divided by f of x plus 14, right? So to be able to visualize this clearly, let's get these equations, right, so that we determine the maximum value. I think we have been solving quite a lot of questions on this. I'm just going to drop a link also so that you check this kind of question. I think in some past papers they were coming, they are set differently. Sometimes you get it in 1.3, right? So second derivative of f of x, so we derivate first, then we derivate for the second time, right? So f prime of x will be the first derivative, so that will give you 2x minus 2, right? So for second derivative, you derivate the first derivative again, right? So second derivative, when you derivate this, it will just be 2. Okay, so I can just go and rewrite that expression of f second derivative divided by f of x plus 14. It will be 2 over f of x is what? Is x squared minus 2x minus 11, and we are saying plus what? Plus 14. So this will be 2 over x squared minus 2x minus 11 plus 14 will basically give us plus 3. Okay, so we have this. So the question says, what is the maximum value of this? Okay, so this is kind of a reverse question where they are looking for a maximum value, but for you to get a maximum value here, because it's a fraction, for a fraction to be large, we have to be dividing by the smallest. You understand? So in a way, we need to know what the minimum value. If we can get the minimum value of this denominator, then we can basically find the maximum value of the whole fraction, because a fraction is large or it's very big when it's divided by smallest number, right? Because if you are dividing by a bigger number, you are reducing the answer of that fraction, right? You are decreasing the fraction. So for this to be maximum, the understanding is that, or the trickiness is that you have to find the minimum of the denominator, so that you divide by a smallest value so that the overall answer becomes largest. So that's the trick really. So to get the minimum of this one, and you can just go and get its turning point, right? The turning point of that, then because this is a graph of, it's a quadratic function that is like a smile, right? So obviously its minimum is there at the turning point, is the y value at the turning point, right? That's the minimum of that. Or some of you might have noticed that actually what they did is on f of x they added 14, so they shifted the minimum value of f of x by 14 by adding 14. So you can just go to the minimum value of f of x, which was what, which is the y value at the turning point there, which is minus 12, and they added 14, right? So minus 12 plus 14, it will be what? It will be 2. So it will go up until because they've shifted the graph, it will go and start at 2 there. So the minimum of f of x plus 14 will be at 2, right? Or rather, you can just go and get the turning point of this graph, and you will see that the y at the turning point will actually be 2 as well. Okay, so we're just gonna go with that idea to say our f of x, the minimum value, which was at minus 12, we have now added 14. We are shifting the graph by 14 units upward. So the minimum is now at what? At positive 2 under there. Okay, so basically the minimum there under it's 2. So we have 2 over 2. So the maximum value of that thing will just be 2 over 2, which is equals to what? Which is equals to 1. All right, I hope you find this helpful. Let's go to the last question, which is about 7 marks. Quite very interesting, really. And that is 5.8. Okay, let's now look at this 5.8, right? Quite very interesting question, really. It has 7 marks, right? And that's where a lot of people struggle when it comes to this question, right? So I'll do it in 2 ways. I want you to understand this visually and also understand this algebraically, right? Using solving and all that. So it says, for which value of values of m will x plus m squared minus 2 into x plus m minus 11 is equals to x minus 1 have 2 different negative roots? Okay, so this question is really packed. There's a lot in it. So if you check what is happening here, you recall that you can see that this was basically the graph of f, right, of f of x, but it's like f of x plus m, right? So we are shifting the graph to the left, right, because they are saying plus m, right? So they want the value of m such that when we shift this graph to the left, we are shifting it to the left, it will be the same as the graph of x minus 1, right? So the graph of x minus 1, remember, it was what? It was the graph of what? Of h of x. So they are saying, what is the value of m that we can shift the graph of f with, such that this graph will be the same, will be intersecting with the graph of h of x, but they should intersect such that those intersection, those roots are actually 2 and they are different negative roots. That's what they're saying. To say, how can I shift the graph of f such that where it is intersecting with the graph of h of x, we'll have those intersection as 2 negative values of x. That's the idea, right? So the graph that we are shifting, really, it's this one of f, right? And obviously we are shifting it to the left because we are saying plus m. So how can I shift that such that that graph, when it's shifted to the left, then it will still be intersecting with the one of h. This is the one of h, right? Here is it. Such that it will still be intersecting, but where they are intersecting, there must be 2 roots. That is the x values, they must be 2 negative and must be different, right? So we are trying to shift this graph such that it's coming this side, right? Basically, we are shifting it so that it comes this side, so that at the end, you understand, if I shift it, I just need to know how can I shift it such that it goes that side to the left, such that because this will ensure that the roots, the x values, they are 2 and they are different, they are negative as well, they are on the negative side. That's the idea really with this question. Okay, so you can see that because I'm interested where the two graphs are intersecting, so you can see F and G are intersecting there, right? At least for the first part. So to say, what can I add to this value of x here such that I shift it such that intersection, it's no longer there, but it's somewhere on the negative, right? It's somewhere there on the negative, so that portion, this portion here, is now this side on the negative. Okay, so that it comes that side on the negative, right? So basically what we have to do at this point, you can see that if I have to shift that point from there to that side, so that when they intersect, when they still intersect there, they still on the what, on the negative side, so that the intersection, the two roots, that is the two x values, are negative. That's the idea really with this. Okay, so now to do this, you realize that, okay, I need to shift this x there to put it somewhere on the negative, right? So I need to know from that how much is it from that point of intersection here towards this one, right? So basically I can first calculate where the graph of f of x, right, it's equals to what? It's equals to the y-intercept there, so that you understand we get what is that x that the graph will now have when it this side. Okay, so shifting that turning point from here towards here, so that I know that my m will just be greater than that x that I will find when that graph is now there. So that in the end, guys, our graph, it's like shifted this side, and I know this one. So if I know this x there at the y-intercept of the graph, so I can know how much I can increase with. So I'll just say m greater than that value. Okay, so that's the first idea. So we're just gonna solve that as well, right? But quite clearly, because this is a bit of a confusing question, but it's not really that confusion if you know what must happen, right? But quite clearly, we must also know the restriction, right, to say the roots must be two different roots that are negative. So obviously here the roots must be what? Must be real, right? The roots are real, but it's just that they need to be negative. So the negative will be accounted by us shifting that point from there towards the intersection at that point there. Okay, so but the key thing really with this question is that the roots must be real, because they are saying they must have two different negative roots, right? Negative, they are still real, right? We know that our delta must be what? Must be greater than 0. So the first thing really is for us to go and simplify that equation such that we calculate delta, right? So perhaps let that be our first step. I'm just going to simplify and expand and group the like terms like that. So x plus m squared, it will be what? X squared plus what? 2mx, right? Plus what? Plus m squared when you expand x plus m squared. Okay, I'm just gonna remove by minus 2x minus 2m minus 11. Then I take the x minus 11 to the other side to be minus x plus 1 is equals to what? Is equals to 0. Then now I can group the like terms, right? I have x squared, right, plus the ones with x, let me group them same time. Perhaps I can say minus 2x minus x, which will be what? Which will be minus 3x. Okay, then I have plus m squared. I have minus 11 plus 1. So okay, let me add this, plus m squared minus 2m, right, minus 11 plus 1, it will be minus 10 is equals to 0. Okay, so when it's like this, you can't easily identify what is A, what is B, what is C, right? So let me just go also and simplify. But we do know that A is the quotient of x squared. Anything multiplying x squared in this case is 1, right? So B is anything multiplying x, but there are two things there. So you can just go and take the common factor of x there so that you know what is multiplying x, right? So let's start by doing that. I have x squared plus, I can remove x, I'm left with 2m minus 3. So you can clearly see that things that are multiplying x there is what? Is 2m minus 3, which is your B, right? Plus m squared minus 2m minus 10 is equals to 0. So now you can clearly identify A, coefficient of x squared, anything multiplying x squared is 1. Then B, anything multiplying x is what? 2m minus 3, right? Then C, it's anything that doesn't have x or x squared. So our constant there, it's m squared minus 2m minus 10. Okay, so after identifying this, I can go and calculate my delta, right? Delta is equals to b squared minus 4ac. Okay, but in this case, we know that these roots are real because they're saying they must have two different negative roots. So we know that delta must be greater than 0 for us to get real roots. Okay, so I just go to my equation of delta and substitute, right? So that let's solve for delta. B squared is 2m minus 3 squared minus 4. My A is 1. My C is m squared minus 2m minus 10. Okay. So when you expand there, when you expand these and all those things, I won't do it for the sake of time, right? But when you expand it, you're gonna get your delta to be equals to, when you simplify add like terms like that, your delta will be minus 4m plus 49. Okay, so when you have expanded and grouped the like terms, so that is your delta. We know that our delta for the roots to be real, because these are real roots, it's just that there must be two different negative. We'll account for that and we're gonna do that. So these roots must be real, meaning delta must be greater than 0, right? So I'm saying minus 4m plus 49 must be above 0, right? So minus 4m must be greater than minus 49 if I take 49 that side. And I'm dividing by minus 4 minus 4. Don't forget what happens to the inequality. When we divide by negative, the inequality sign change, right? So it will be less than what? 49 over 4. Which can be simplified as what? As it's gonna be 12.25. Okay, so our m must be less than 12.25. All right, are we done? We are not yet done. We just got the values of m that will ensure that these roots are what? Are real, right? But then the question wants there must be two different negative roots. How can we also ensure that these roots are also negative? Okay, so our m that we got there is just ensuring that the roots are real, right? But the key thing is that there must be two of these, they must be different, and also they must also be negative. Okay, so how can I ensure that these roots are negative? It means now, as I've stated initially, we have to ensure, remember, where the graph of f is equals to the graph of h, right? Intersecting this, I have to make sure that this point, it moves from that side and it goes to the negative side, right? So basically, I have to move the point there at that point where I'm highlighting. Let me just show you with this. I have to move that point of intersection there, and it has to shift to go to the negative, right? So far, you can see that we can shift it and put it there at the y-intercept of the graph, and we can just know what is the x that will be for the graph that when it's now there, right? So now my new graph, I want to ensure that my new graph actually is starting from there. So if I put it that side, right, that point there, maybe let me use a different color for this new graph. So if I put it there, the y-intercept there, right, if I put my new graph there, you'd actually notice that if I know the x there, then I can have known how much they've shifted it to that side, right? Then I can just say that m must be greater than that x that we'll probably find there, right? So that it's now on the negatives. So your graph now will be having two negative roots that are unequal. Okay, so that's the idea. So now we just got the restriction that m must not exceed 12,25, but we do need to know what is the value of m when you shift that point there, because they are saying where the two graphs are equal but negative roots. So for me to get that shift for the graph, I'm saying I must shift it to the y-intercept of that graph, right? Which we know that because the graph is x minus 1, the y-intercept of h there it's negative 1, right? So I'm gonna equate my equation of f of x to what? To negative 1, so that I can solve for that x that will be there. Then I can just say it must be above that, so that it now goes to what? To the negative, so that our roots are two negatives. So that was the trickiness of this question, really. Okay, so I'm just gonna delete some of this to create space. So we are saying we want that value of x where this f of x is now equals to the y-intercept there. I need to just know what will be the x of that graph when f of x is actually equals to the y-intercept there when it goes there to minus 1, right? So the graph was x squared minus 2x minus 11 must be minus 1 equals to minus 1. So x squared minus 2x minus 11 plus 1 equals to 0. Then this is minus 10, right? So I can just solve for this x, obviously using what? Using quadratic formula. So when you use quadratic formula, because I've already calculated this, so on your quadratic formula you're gonna get x equals to 4,32 or x equals to negative 2,32. Okay, so we are not interested in the negative one because we are shifting the graph to the left, so the x there, we are interested in the m that will be positive. So you find that the x there will be what? 4,32. Okay, so we must have shifted it by 4,32 so that it goes exactly at the y-intercept of minus 1. But I'm saying the roots must be negative, so I want it to be that side there, to just simply to be above 4,32. So you can see my m must be greater than what? 4,32. So I must shift it by above 4,32, because if I shift it by exactly 4,32, it's going to be there at the y-intercept, right? So for it to give me negative roots, right, to come that side now, to be at least above that thing, because at that point the root is still positive, right, because it's exactly at the y-axis. So for it to be above, I must shift it by more than 4,32, but the restriction here, so that they remain real roots, it must be less than 12,25. So finally the values of m must be above 4,32 but less than what? Less than 12,25, to ensure that these roots are still real, but again giving us two different negative roots. Okay guys, I hope you find this helpful. Don't forget to like, share, comment and subscribe. See you soon. Bye.